Hello, are people here? Are people here? Yes, somebody says yes. Okay. Let me tweeterize about this. I forgot to change the name of the stream. Let's do that now. It is compiler profiling. All right. As always, I'm going to get some tea going and then we'll be ready. Hello. Yes, we did get improvements in the compile times from the scope refactorings, for sure. In fact, well, we'll look at the profile today, but identifier lookup, when I glanced at it before the break, was actually not as expensive as I expected it to be. So I think any profiling effort would go elsewhere in the near term. I mean, it's not that expensive now after those optimizations, right? Before it was dominating. Can I talk faster? Okay. How's it going, everybody? Today we're going to talk about compilers. All right, we'll give people a couple more minutes. Any small questions before we officially begin? Why does it still say compiler bug fixin down there? What, I modified that. I said compiler profilin apostrophe. Why does it not change? Done. How long does Sokoban take to compile now? Well, with the x64 backend, which is the faster one, about 1.05 seconds. I'll do that a few times so you can see some numbers, which is, you know, I'd like it to be faster than that. Part of that is, oh, is my camera looks like it's pointed somewhere weird. Oh, I'm a little bit low on the, all right. So, you know, half of this is our front end time. X64 is taking longer than I would like. I don't know why that got so slow. So we're going to take a look at that at some point, maybe not today. But it's like, it's linker. Linker is 40%, a little less than 40%. And that is because we're running Microsoft's link.exe. However, you know, like I've said in previous streams, LLD is faster. But I have an idea for how to reduce the link.exe time, right? So the link.exe takes as long as it does. Well, we're using it because LLD didn't do a good job with debug information, but for the fast build, you maybe don't really want debug information. So what I can do is when we go and address the custom build command that I noticed no longer worked during today's bug sweep, I can go make it so that, just like I said, x64 here on the command line, so that I can give it the option to use LLD instead. And that should give us, I don't know, an extra 0.1 seconds, 0.15 seconds. I don't remember exactly. Is LLD in my path? I don't remember if the command line arguments are the same. They probably aren't. Maybe they made it compatible. Let's see. LLD link. Can I forget it? Forget it. I'm not going to the beginning of that. Anyway, link time was about 0.17 in reboot. Okay. So I would expect it to take a little longer than that because the program is bigger, right? The program, I think during the reboot talk, you know, when Sokoban gives this output, I think I remember this being 45,000 lines at that time, right? So we're substantially bigger. So maybe the link time has gone up proportionally. but it'll be faster than 0.4 seconds, I'm pretty sure. Am I going to schedule any upcoming sessions where I go back and address some of my annotations in the code? I've said before that I leave them a lot, but don't return to them often enough. Well, so the way I'm doing it is I do use those sometimes. Like when I go and address a bug or I'm rewriting a system, those help direct my attention, and often I'll take care of those at that time. And we've taken care of a few of them during these past few days. However, it's true that a lot of those are still just hanging out in the code. And the reason is just they're lower priority generally. You know, if they're not affecting functionality, and if they're not in the parts of the code that I'm most worried about complexity-wise, then they're mostly fine for now. But yes, at some point, I do want to do a sweep where, and maybe it'll be fun to stream that, where I just spend a few days hunting those down, right? That'll feel good. But I think that is lower priority than, for example, doing better library functionality or doing the couple of remaining new language features that I want to do. And getting, I'd rather get the language out, the compiler out to the initial user base before, holding that up in order to do those lower priority things. But I do agree that it's something that should be done. How many lines is the witness? I don't remember. It's something like, it's a different metric than this, right? So by this metric, where you don't count, new lines and comments. So the compiler is 41559. The witness, I'm pretty sure it's at least 240,000 lines, right? So it's like 6 compilers glued together. Six compilers of the current level of complexity glued together. Something like that. Yes, I am running on an SSD. Do I think running from a disk would take sufficiently longer to compile, or is the file loading an insignificant factor? The file loading here is 11 milliseconds. So that probably wouldn't be as fast if you had a disk drive, but it would only be slower by adding the latency and throughput involved in finding a small number of source files. It still won't be that bad. This is parallelized. We'll see that when we look at the profile. Were Braid and the Witness made on a ready game engine, or did we make them from scratch? We made them from scratch. Any updates on when something might be publicly available? We have no concrete schedule for that. It's just we're going to try and do it when we can. People ask that every single stream. Every single stream. It is the most common question. What am I going to use profile the compiler, off the shelf or self-made? We're going to use an off-the-shelf profiler called telemetry that people who watch my streams may have seen before, but we haven't busted it out in a long time. If I were to write a web server, would I use an existing engine or make a fresh one from scratch? It depends on what my objective was. If I wanted to serve documents really quickly and I didn't care that much about weird stuff, I would write it myself, but I'd probably use someone's HTTPS implementation, right? but I wouldn't have like a PHP equivalent, and I wouldn't have, you know, all these weird config files with different syntaxes like these web servers have, right? It would be drastically simplified and made to crank files to people fast. But I don't want to write a web server, it's true. Yeah, telemetries by Rad Game Tools. Okay, let us run the profiling build. So in Visual Studio, we have a telemetry configuration, and I have built that. And we can run it. I ran it before as a test to make sure it worked. Where is it? I must have run it from the other shell. There we go. You know, it's just executables in a different folder. It runs slightly slower than the release compiler, like 10% slower, because all the profiling hooks take a little bit of time to execute. But here I'm going to run it, and I'm going to run it about 3 times just to get a little bit of variance in numbers so that we can see if something's an outlier, if it looks troublesome, or if it happens in all 3 runs. And so this is the UI for telemetry, and when we, whoops, I didn't mean to grab that. I meant to grab this. No, I meant to grab this. When we run the thing, the profile will show up there, right? So first run, boom. So it took 1.15 seconds, right? Oh wait, we didn't, did I run the right one? It says connected to telemetry server. 9:25. I guess I closed the window. Oh, here we go. I must have closed. All right. So we've deleted all the runs. So there's one. You can see the data sort of going in as we run. 2, 3. So it's really not that much slower. You know, we're taking 1.1 seconds to compile. So we've now got profiles for 3 runs here. And let's just look at what this looks like. This is the first run. And because I've looked at this in a profiler before, I can tell you generally what all this means. So every one of these big horizontal rectangles here is a thread, right? So main thread, blah, blah, blah. This initial main thread, oh, and here's the timeline, right? So it's, you know, here we're at about 1.15 seconds, right? Here's the 1 second mark. The first thing you'll notice before I say anything else is that all of this right here is, well, this part is the linker right here. So everything from about 710 milliseconds till the end, we're just waiting for the linker to complete, right? This part before that is we're building the object file, and that takes longer than I would like. So we'll probably look at that. We probably don't have it instrumented well enough right now. Everything before that is the rest of the compiler. Because we generate object code all at once in one swoop, the nice thing about that is we should be able to parallelize this pretty easily. So, you know, we're running 12 threads right now. So, you know, we should be able to divide this at least in 4 or 5 on 12 threads. So that'll go down. But, and then of course, if we switch to LLD again for the fast build, this will get shorter. But zooming in a little bit to ignore the linker, that was a little too much. Oh, we can't zoom in that much. So ignoring some of the linker. Up here, this little bit is this thing called the preload, where we basically load all the structs that the compiler needs in order to do anything. So this is overhead that happens before we start loading your program. Once these jump in, this is loading the actual program. So lexing and parsing is parallelized right now. So these little strands of color in all of these are when we're using CPU time. So like we load some files, we load an initial burst of files all in parallel, and then the compiler is doing a bunch of stuff, and then eventually that stuff is done enough that we can lexin parse more and lexin parse more and lexin parse more. So, you know, there's like 4 distinct phases here. And I'm not sure why it's 4. Like why? So some of this is like, I can actually zoom in and know exactly which files are being loaded. So like tests and shadow map. And I think it might be just that we used all our cores and then we ran out of jobs for the job system and we're waiting for something. I don't know why these are so far spaced apart. That's something to investigate. But I'm not that worried about it. Because if you actually look at the time that this takes, it's really not, you know, it's not a lot of time all told. So if there are latency issues in there later, we can get to those at some point. Any questions about what we're seeing so far? Oh yeah, I forgot I don't need to necessarily move the mouse pointer as much because when the mouse pointer and the eye tracker are flying around, that's kind of crazy. So maybe I consciously try not to use the mouse pointer so much in this case. Hey Chris, how's it going? So does anyone have questions about what we're basically looking at before I start diving into things? Oh, you know, maybe I should try to make the text bigger. Is the text too small? Is it like really blurry and hard to read? I think I can go in here and UI, font scale, 201. We'll go smaller, because I want to be able to fit enough information on the screen still. Is that more readable? Yeah. Okay. So now the part of the compiler that is not parallelized, well, there's a couple parts. There's the type inference, right? And the bytecode generation, or this is machine code generation, sorry. Bytecode generation also is not parallelized, and that's mixed in here. And things are color coded, right? So red is like, hey, we're running procedures and waiting on the main loop, okay? Anyway, so these threads are all lexing and parsing. This one is the meta program, right? And so this meta program is doing a bunch of message send and receives on this core for a while. And then it's basically spending all its time waiting on messages. Like it's doing messages with great frequency for a while, and then it's just waiting for a while as all these infer things need to come in, right? I do think I'm kind of not that happy about how long it takes to compile the meta program right now, because for the first, let's say 70 milliseconds, we're all meta program here. So maybe we need to look at what the dependencies are and reduce them, or maybe we just need to make the compiler faster. Okay. So the first 70 milliseconds, we're compiling the meta program, then it's up and running. So then down here at the bottom is type inference and bytecode generation, which are not threaded. And then this thing perform loads is a task that launches all these jobs and waits for them, right? So actually, that's probably what's going on here, is that we only call perform loads once in a while. And maybe if that were more asynchronous, these would be packed closer together, right? Because like we're doing this inference, which means we're maybe not loading some things for a while. But it probably doesn't actually matter right now, but it may matter eventually. Yeah. Anyway, so then, well, you can see we spend a lot of time. So like for this 25 milliseconds, we're inferring types. And then I can actually zoom in and see what the hell we were doing that whole time. So here we're pumping the infer type, which has a lot of items in it. And then it's just, you know, remember when I did the Lambda refactor 2 days ago, I was talking about this queued structure, which like recorded the information that we use to send stuff through the pipeline, right? Each one of these is an infer of one thing. And some of these are taking a long time. Well, I don't know, 28 microseconds may or may not be a long time. But here, 28 microseconds, and it's dominated by a single identifier lookup, right? Not always, right? So these are not dominated by identifier lookups, but sometimes the identifier lookups are expensive for some reason. So, but we can actually, we'll look at a view in a little bit that lets us quantify exactly how much they matter. Anyway, so we basically go through and do a bunch of these nuggets where we infer every top level declaration in the program. There's thousands of these, which is why when you zoom out, they look really tiny. And then eventually you start seeing this blue, which is when we start building the bytecode for different procedures. Sending messages to the user program about what we have compiled. And, you know, I don't know. So this gives you some idea. Like if you're wondering why a particular task took a long time, you can dive in and look, right? And then this purple stuff is array operations. And it's a little bit disturbing when they take a long time. Or no, these are hash table operations. So this one took 50,000 clocks. And it's like, why did that take so long? You know, 20,000 clocks. So we need to maybe investigate that. And then polymorphing procedures, surprisingly, not that much time. Right. So these two purples are different things. So maybe I should color them different colors. But once you have too many colors, it becomes crazy. But this purple is like, you know, our version of template metaprogramming, expanding those templates into procedures that can run. And you notice there's not that much of it proportionally. You know, it's maybe 10%. It sort of disappears. As you zoom out, it's dominated by the blue, although, you know, sometimes it becomes more dense. Like here, we're probably inferring a procedure that calls a polymorphic procedure and so forth. I just spilled tea on my Gamma Brothers shirt. Short break while I wash the tea out of my Gamma Brothers shirt so it doesn't stain. I'll be back in a second. Any questions that you have about this direct to me? This is not anything related. I didn't write this software, Chris. This is somebody else's. We're just using it to inspect the behavior of the compiler. Back in a second. Well, that is the occupational hazard of drinking tea while working. Someone says weight polymorphing is faster than identifier lookup. Well, sometimes, maybe. I mean, yeah, well, this one is definitely slower. So this one is 15,000. This one is 60,000. So it's 4 times identifier lookup there. But this one is 80,000. That's slower than a polymorph. So, sometimes polymorphs might be copying a very small procedure. It might be a couple of lines. And I really don't know what this one is doing to take 80,000 clocks. Maybe there's hash table collisions. Maybe we're doing something dumb. It's unknown at this time. So, these are things that have to be investigated. Does telemetry work with most compilers? Yes. So the way this works is you actually manually mark these zones in your code. This is not every single procedure. This is things that I have marked. And you can put information in the way that they are marked, which is why, for example, when we're loading files, that I know what those files are because I gave that information, right? So, we load scroll bar in 1 million clocks. We load OpenGL in 6 million clocks, right? So 2 milliseconds. 2 milliseconds to load OpenGL. Oh, that's not the OpenGL library. That's my OpenGL side. That's the side of the game that does OpenGL, right? And some of these numbers are higher than I would like, but the lexer and parser are completely not optimized right now, right? Because they're just fast. They're not the problem, right? These things are not the problem speed-wise. It's these things. It's the type inference that's the problem. Okay. Yeah, you add very little instrumentation, right? There's just a thing you say like TM zone at the top of any given function. Okay, so I can go over here and I can say profile zone. And this gives me like a more classic profiler view of everything below this thing that I looked at. And I can do, always when you use profilers of this kind, there's 2 things. You can look at the amount of time used hierarchically by that procedure and everything below it, right? Or how much that's inclusive time, right? And then exclusive time is how much was used by only that procedure, not counting people that it called, right? So if you want to prioritize, you can be like, oh, infer types takes 260 milliseconds. That's half the front end time, remember? Because we said the front end time was 500 milliseconds. But then in this function specifically, it's only 10% of that. So 90% of the time is in routines that are child routines of this, right? For example, this one, well, 237 hierarchically, which is about this minus that, right? So that's no mystery where that time went. And then 20% or 30% almost, 25% of that time is spent in this routine itself, not even going into child routines. So that starts to tell you like, maybe that's a little expensive. Maybe we could do something about that, right? Identifier lookups, assuming that this is the main routine taking time there. The sum total of all identifier lookups is about 80 milliseconds. Whereas the sum total of type inference is 250 and the sum total of the frickin' linker is 400, right? So this just tells you how much you have to gain by optimizing each of these. And so identifier lookup used to be a lot worse than this. And now because we did that hash table thing, it's a lot less, right? What did we say? We went from like 750 to 510 or something like that. So we saved, we probably saved over 200 milliseconds on identifier lookup. Somebody who has the stream can go, well, we all have the stream. It's on YouTube now, but someone who remembers maybe can tell me, but, oh no, it was 600 and it was between, depending on the run, it was between 680 to 700. And I think we got it down to 530. So we saved about 150 milliseconds on identifier lookup. So if we had been looking at this last week, this would have been 150 plus 80, which is 230. So this would have been almost as bad as almost as bad as all of type inference, right? So we did a good job the other day, is what I'm saying. Okay, messaging to the application is slower than I would like as well at this point. It's 70 milliseconds, which is starting to be an appreciable amount of time, but that is also not parallelized. And I am hoping that we could parallelize that. I don't know. I mean, I think probably. Put that in the job system. Emit code, this is bytecode generation, 60 milliseconds, which doesn't seem too bad. This send messages, that's just the message passing to the outer program, I think. Whereas do export is making the messages. So together, this is like 150 milliseconds, that's starting to be enough that maybe it's something that we think about optimizing, right? Polymorphing altogether is less than 50 milliseconds, right? So it's about 10% of our front end time right now, which again is non-trivial, but also not as bad as type inference. And then we go on down. And from here to here, all these components are like the same order of magnitude generally, right? But so it seems to me that it's pretty clear that type inference is the next thing to speed up. And there are three things to do. One, change the overall structure with which I do it, right? Let's go highlight type inference again. Change the overall structure with which I do it to like an algorithmic change, right? Part two might be just micro-optimizing the code, or at least doing a cleanup pass to try to figure out how to do what I need to do a little more cleanly. And part three would be to parallelize it. And, also sort of part 1.5 would be maybe there's a way that we can have type inference not have to chew on so many things, and I might make an attempt at that tonight. So where's like pump pipes and stuff? So, anytime we have a pump pipe procedure, that's, handling all these things that go through all these queued structures. And we make queued structures for every declaration at top level. And here's the thing. Stuff like Windows or whatever has like a ton of declarations like this, right? OpenGL has this too, where there's a ton of stuff. And you probably do this a lot in your own program where you have enums and stuff. And right now when we see a declaration like this, we put it just through the whole pipeline. We pretend like we don't know anything about it, and we're just like, just go through this multi-stage thing, when in fact, as soon as you parse this, you actually know everything about it. Especially now, because like way back when I started making the compiler, the rules about how we solidify types of integers were not that clear, right? Now they're very clear. Like as soon as you parse this, you can put a signed64 type tag on it and you're done. So I might do like a short circuit for that. Like, look, it's just, we're not even including a lot of these things. A lot of these, it's just Windows is full of this stuff. And then, well, let's go to OpenGL. Right? Hey, look, more of the same. Like a large percentage of the OpenGL declarations are like this. So, I mean, I don't exactly know how many, so maybe I would just put in some code to count how many things are like this. But if we can get all of these to skip the line and just be signed 64-bit constants, that might take an appreciable amount of load off the thing. Do we have incremental compilation? No, not currently. I imagine that for very, very large projects, eventually we will have incremental compilation, but I don't want to have to do it for years, right? Of course, you can make a meta program that compiles your program in pieces and then links those together if you want. But I don't think much of that because those kind of things always go wrong. Visual Studio gets that stuff wrong sometimes, right? I like the confidence of hitting a button and knowing that my program is freshly compiled and nothing was like incorrectly cached or whatever. So that's my overall summary. So I guess, what do I want to do today? Okay, one thing I could do in this stream is I can just put together something that tries to count these declarations. And then I can use, like, do we have a thing in infer types for a declaration? If not, we can put one there. I guess we don't, but we can add that. And then we can know how many declarations there are total that we infer. And we could see how many we would skip. So that's one thing, just to test that hypothesis that it would be a significant number. And then, of course, we wouldn't just, so then that would be, okay, so here inferred types for a queued, we call that 45,000 times. That doesn't mean there are 45,000 top-level top-level things. For example, things can stall and wait and need to come back and be reevaluated. Things could be resubmitted by the meta program to be modified. So this is some multiple more than the total number of top levels, but still, however many declarations those are, we would know out of the 45,000. There can't be more than a couple thousand, right? I mean, even in all those declarations that I paged through, could there really be more than a couple thousand? That would be 5% benefit. But 5% benefit to the majority of the compiler would be pretty badass, honestly. I don't know. I don't know. Okay, what do people think about all this? Should I go on and start trying to do things? So the way, when I talked about an algorithmic change, so things like this ensure flattened, that's the kind of thing that I'm talking about changing. And I would probably do something more like a recursive tree visitor, because the flattening approach, which I've talked about before, but probably very few people watching this stream saw that technical summary. It was a way of being lazy, and I was like, oh, this will probably be good enough for what I want to do. But actually, it has a lot of drawbacks. And we spend a significant amount of time laying out data that we then read back. So I would rather try a tree visit approach. I think that would give me more flexibility and would be faster overall. So, yeah. I don't know. Questions? Do you think just special casing literal declarations can have a significant improvement? Well, like I said, it depends on how many there are, right? Obviously, if the percentage of those, if the amount of time those are already taking is a negligible percentage of the program, then it doesn't matter if you make them infinitely faster, right? Because the amount of time that disappears will be small. So what I want to know is how many of those constant declarations would I schedule? I just want to know that. I just want to... Will we have futures, tasks, promises? Probably not. Not at language level. You can build those as a library, but like, I don't understand why those are... Like promises especially. A promise, as far as I can tell, is just what you do when an asynchronous job is computing a data structure. But like somebody had to come up with a weird name for that. It's like, what? Like, can somebody explain to me what promises do? You think the system of flattened type queues makes searches and type work very flexible, maybe just some early out when queuing? Well, okay, so here's the thing. I think there may be some benefit to having that flattened stuff for user programs, because it makes it easy in user programs to like search for identifiers and stuff. I've been very happy before with how easy that is. But you could always just call a flattener at user level and use the flattened array that it gives you. So me flattening that in advance is assuming that you want it flattened, when in reality, I think a lot of user programs don't need that much flattened. I don't know. Promises arose from JavaScript because you want a function that depends on a callback to return an object that has callback handler instead of you passing the callback into the, whatever. You just don't want to be that deep into callbacks in the first place. Callbacks are just fundamentally bad. You don't want them if you can avoid them. And I posted that on Hacker News one day, and I got mega downvoted by all these kids who don't know any better than to not avoid callbacks. Okay, let's do this, and let's just use telemetry to do the counting since we're using telemetry, right? Right. Okay. We didn't end up using these other two runs, so Oh, come on. Come on. I can't drag this side. Wait, there we go. Let's close these. Okay. I want to count declarations in a data scope that have no type instantiation field. And we're even ignoring these. Actually, stuff like this that's a primitive type, we could also short circuit, but no. I want to count declarations that have an integer literal on the right-hand side, or even a float literal, a number literal, any number literal on the right-hand side, and no instantiation. And then, okay, there's an extra thing that happens, which is when you make an import link to one of these, I maybe want to count that also, but initially let's just count these. And then also, I want to do infer types of declaration, because this might get re-entered multiple times too, but to a first approximation, this will tell us how many declarations we have. Yeah, so we've got that zone. And then what did I say? Oh, we want, when we add a declaration to add to scope. That's in scopes, which we did the other day. Add to scope. This might overcount a little bit because of static if. Declarations would be counted twice. But again, we're just looking for a first approximation here. Wait, has been added. What does that do? I want to find the thing that schedules. Yeah, this is the thing that does some queuing, right? Should queue. So what our eventual check would be is like, if this is one of these simple declarations, should queue is false. And we just poke the type right in here when we put it in the thing. Okay. This no check-in will actually cause the server to reject this if I forget and try to check it in. Okay, so this is going to be called found a simple declaration. Okay, so if something, we TM zone that in k equals 1. We just want to use this as a counter. Okay. So if we're in data declarations, if no type instantiation and decal expression and decal expression type is asked literal and static cast asked literal, decal expression, value type is value number. In reality, we can also poke strings and stuff, but not really array literals. Wow. Here, let's do this. What are my literals? I'm not even doing the right thing. Value type, yeah, it is. Literal number, not value number. No. Okay. Literal number, literal string. So these are probably the ones that we can do something about very easily. Number, oh, I didn't. Okay. Okay. Well, let's run that. Oh, good. My shell is telling me attempt to index a nil value. Remember what we were saying about scripting languages? Thank you, Lua. All right. Such a professional stream. All right. 9:25 p.m. No, it's 10:07 p.m. Why is the duration so much shorter? Wait, what? I don't trust this. Did I hose it by sending it too much data? Like, what's going on? Okay. Okay, people. Let's go back to here, profile zone. Now, oh shoot, wait. Do those add to scopes? I think they maybe happen in the parser. Can I profile everything? Profile view. Oh God. Yeah, oh God, this is not going to be so easy. Can I just say how add all these up? These are happening in all the individual threads. Well, let's just add them up. Computers, they never do exactly what you want. There's no found in anything there. Found a simple decal, 193. Found a simple decal, 184. Found a simple decal, 109. This is not adding up to a very high number. Found a simple decal, 742. Oh, that's good. Found a simple decal 405. Found a simple decal 723. Found a simple decal 1755. Found a simple decal 194. This is not sorted by. Found a simple decal 10. Got to add that 10. Found a simple decal 128. So remember that number before was like 10 or 45,000. So this is like 10% of all our declarations. More than that, remember, because that 45,000 includes reinfers. That's not that bad. And it's probably twice this much because of the way that exporting works. We're going to do an extra thing to count these. But you know what? I'm just going to add an integer instead of using telemetry for this because the fact that it's spread across all the threads makes a pain in the butt. But the infer is not parallelized. So we want to know infer types for single declaration or whatever it was called. Infer types on one decal. 7,000 only. Are you kidding me? Wait. These numbers do not add up. Because I mean, inclusive time there is less than 1 millisecond. What? How does that make any sense? How is it only 7,000? Maybe we infer declarations another way accidentally. If there's only 7,000 declarations, which I get 7,000 top level declarations or data scope declarations, which includes things inside structs, I would believe that in a 70,000 line program because a lot of things are white space and comments and a lot of things are long procedures, right? So that means that we're re-entering and trying to do things like when we have the, wait, 9,000 only? What? How is this so different? Oh, it's the wrong thread. This is the one that just has the meta program, folks. Let's do this one. Duh, okay. I was going to say, okay, so infer types, okay, infer types on one decal, 36,000. Okay. I think that, I believe that number. I think Well, 4,000 is more than 10% of that. But I think we can do even better than 4,000. So, because the thing is the following. Wait, where was it? Where was has been added to scope? Okay, has been added to scope. Now, the way that scopes work right now is that stuff gets added to a file scope, and then if the declaration is exported, which most of these are, then it also gets an import declaration into the global scope or the outer scope, and that also gets queued, right? So there's probably very close to twice as many. So we're going to do the following. If extern int simple decal count, if is simple decal simple decal count plus plus, else if decal import link and is simple decal import link simple decal count plus plus, inline bool is simple decal as declaration decal, like that. And then we need to have simple decal count. I'm going to do this, and then we're just going to do that. Sham bam bamina. Would I consider adding the for else construct? The stuff in else runs if the for loop terminates without any break. I don't know. I mean, people have suggested that. I don't really see the need for it. Wait, it's if it terminates without any break? Why isn't it for then in that case? Like, I don't know. Else doesn't make that much sense. Okay, let's run this. Did we get a full readout that time? Come on. Yeah. Okay. Simple decal count 8,000. I mean, I kind of have to do this, right? I kind of have to. What do you all say? I kind of have to try and do this on the stream tonight. And then if I mess it up, then I mess it up. $8,000 declarations that could just skip the line. Just be done. Be done. Okay, so first of all, so if we're going to do this, let's run release build and comment out this thing because, you know, the old version didn't have this, right? Of course, let's rebuild now that I modified that file so Visual Studio doesn't get it wrong. Okay, so this is like, there's no simple decal anything going on. And we'll see how much time it takes. Now the trick is I'm probably counting enum members right now, and enum members are going to be more complex to handle. So I will not handle enum members, but I'll also count them when I don't handle them, and then we will at least know how much we're losing there. Okay, so 1.04, 1.05. Okay, so our front end time, the back end isn't going to change at all unless we really screw something up. So we're at about 0.53 seconds, right? This is a little over, this is slightly under, maybe 0.532 seconds, 0.533, 0.535. Are we calling it 0.53? No, 0.527. Let's call it 0.531. 524? Let's call it 0.53. 539. Yeah, look how noisy this is. 526. Let's call it 53. All right. So I'm going to write down 0.53 front end. We want to move that number. If we could subtract 10% from that number, that would get us down to 0.48. And being in the 0.4s is nicer than being in the 0.5s, isn't it? Am I still working on the game engine? Yes. Wouldn't enums be easier to handle since you already know everything inside the enum is the same type? You would think that, but the problem is at this time, when I'm putting this check in, is when we've parsed the thing, right? And we don't know the type of the enum when we parsed it. We can later on do a similar skip the line kind of a thing, but it has to be in the infer pipe. And it's just a little later, but I think we'll be able to get a lot of benefit from that, just not quite as much. Does the parser use recursions or iterations? It uses recursion. If former, how deep does it go? It goes however many expressions, like however deep your nested expressions are is how deep it goes. It depends on the input, which might not be a very good property. At some point, we might want to make it less recursive because iterative things are generally faster. But right now, parsing is not close to the time bottleneck. So there's that. Will I upload more game engine dev videos to YouTube? Probably. It's just I've been doing a lot of compiler work lately. Okay. So let's add, I said that I was going to count the enums. So int unhandled we're going to print that. Now we're going to go here and we'll leave the no check in because if this is a disaster, we don't want to check it in. So if it's a simple declaration, then the problem is, what if somebody, like the thing I'm worried about is somebody might assume that things are queued. Like, I think a struct waits on its members. Okay, here's what we're going to do. We're only going to do things right now that don't belong to structs or enums. Yeah. Okay. If it's a simple decal, if block belongs to enum or block belongs to struct, we do not handle that. Simple decal count is now going to be for things that we handle. And then we're saying should q equals false. And of course, now we have to infer it. So if switch auto literal static cast as literal decal expression, okay, switch literal value type, case, literal number, case literal string, case literal well, true, case literal false, default assert false. Okay, we got to put our breaks in because this is C++. Now, before I fill that out, let's just put assert falses here so I don't forget to fill it out. Down here, if we have an import link, if decal import link inferred type, decal inferred type equals decal import link inferred type, simple decal count plus plus should q equals false, else unhandled. Like for some reason, you know, we didn't handle the guy he's pointing at, so we won't handle this one. Okay. So if it's a no, let's do string first. And we're not going to worry about, not worrying about, oh, well, yeah, we should worry about it. Okay, if it's a string, if literal new string value dot count, else, right, well, so literal inferred type is interp type def string, so is decal, and we also, so the thing is, there's maybe some things that we have to set. So like, decal flags has non-zero init data and literal, right? So, you know, this is how we know whether to put this into what segment and so forth. So we have to do this. So if literal, what are these called now? Numeric flags, yeah. If literal numeric flags and literal numeric float, else it's an integer. If literal integer value blah. Okay. So if it's a float, Is it literal numeric float? Literal numeric float 64. Okay. And then yeah. Well, that's added some lines of code. Number string, oh, literal true, literal false. Something like that. Look at all that code we added. Unhandled simple. Where's the declaration for that? Did I delete my extern? I deleted my extern. Nope. Well, who's taking bets on how badly this crashes? Let's see. Oh my God. All right. So that was the LLVM version, right? So that's not really, although the front end time, okay, wait. This final queues here is the number of queued structs. And it hasn't gone down. It's still 398. Let's write down like 39856. It seems to change every run a little bit, which makes sense because things are threaded and whatever. So it didn't work somehow. Maybe somebody else queues it. Maybe we've got redundant queuing going on. So I'm going to set a breakpoint. In one of those. I was at first dismayed when I looked at the number and it wasn't any lower, but then I was like, wait, it's the same number of things. We're supposed to have 5,000 less things. I'm still surprised that the unhandled is so high. I guess there's a lot of, all the OpenGL stuff is in a struct GL. That's why. That'll be easy to deal with. Structs are easier than enums, I think. Okay. Well, if I messed up something real bad here, then it's no surprise that we didn't crash, because if we don't do anything different, then why would we crash? Okay. So let's just see what declaration this is. It's probably in the preload. It's know it's in string. It's line 1019 of string. Okay. It's inside a static if. We actually don't want to do things inside a static if. Because you don't need to infer them. Waiting on. Yeah. So we'll accept that. Okay. How can you program for so long without your brain fizzing out? Bro. This is easy work. Hard work is like working in a coal mine and slowly dying of black lung. Programming is real easy comparatively. Okay, what declaration is this? Decal. Line 103 of print. Okay, that's a perfectly good declaration. It's a string. We know what strings are. It's all good. Okay. So what happens? Is this already queued for some reason? Queued, no. Okay, should queue is false. It's got an inferred type. It's got non-zero init data. Break. Should queue, false. Okay. Let's set a data breakpoint to see if it ever gets queued. OX49B2DA0. Why did we queue this guy? Why did we queue this guy? Checked add to scope. Because Visual Studio is stupid, we're really on this line up here. Even though it says this line, like, come on, guys. All right. Okay. Why are we checking parent? This is an unnecessary check now. I'm not okay. I'm going to write this down. This goes back to before everybody had file scopes. So if we can remove that if clause, I will feel better about adding this if clause of the following. Let's see if that, we're just going to run the debug build and see if we get drastically fewer queues. Maybe it just crashes. Oh yeah, okay, we're trying to depend, somebody's trying to depend on this declaration now. And it doesn't have a queued. So why is someone trying to depend on this? That's good, it means it never got queued. Add dependency, maybe export declaration. Imported. So, I mean, we could fast track this sucker right here. But, in fact, maybe we should. Maybe this is the best place to do it. But let's just figure out. Make sure we're running with no jobs. We're running bug 174 repro with no jobs, but that's fine. It's good enough. I want to know why that's getting queued. Wait, it's already queued. What? What? Really? Why? Because we did it here. Okay. All right. Here's what we're going to do. In ast.h, we are going to not worry about the import link here. We're going to instead say, when we make the import link, let me see if that's the only place that makes it. Do insertions for using, well, we're not going to worry about that yet. We just want this to work for one of these cases. Okay. So we want this one, maybe export. Okay. If decal inferred type else something. Now that since these things are associated, I want to mark them. Okay. Q for resolve. Depend. And this may not be the only problem of this kind, by the way. So okay. In fact, I'm just going to run this in the debugger, wagering that there is another problem. Do I like a nice Earl Grey tea? Yes, I do, but not at 10:45 p.m. when I want to sleep eventually. Okay, what happened there? Base address has been set. Oh dear. Okay. So we need to limit ourselves to constant declarations. Because declarations that are non-constant do need to go through part of the pipeline because they get put into address space, right? Whereas constant things don't. So is simple decal. Let's try that. What switches on the keyboard? Cherry Blues. What keyboard? Razer Chroma something. Black Widow Adder. Mr. Bean. This is looking promising. This is looking promising. I mean, it takes like 30 seconds for the debug build, but it's looking promising. I need to speed up the debug build. It could be infinite looping for all I know. Nope. Okay. Our simple decal count has gone way down. But this is not any, I forgot to increment it for these import links. Where was that? Now, non-constant declarations we don't have anymore, but we'll see. Templates are slow and they generate terrible error messages. And they cause your compile time to take forever, and they're complicated to use correctly, and they're hard to understand. They are not one of the best C++ features. Okay. Let's see, release. We didn't really save that much time unless we got unlucky. We really didn't save much time. Well, fiddlesticks. So we handled 3,000. We didn't handle 2,000. But we've saved, I mean, our number from before was 0.53. So we've saved 0.07. That's more than 10%, actually, right? Wait, no, 0.007. That's 1.3%, which is non-negligible. However, I had hoped to save more for this kind of code complexity. And Sometimes we're over 0.53 still. I'm bummed. I wanted a better payoff than that. I think I'm going to file this away as I did this, but it's not worth the complexity in the short term, and maybe we think about it again later. I think you saw two closed braces on the same line somewhere in the fast track switch. Intentional? Well, let's see. Not this one, right? Do you mean the big one? Oh, the switch statement in here. Oh, this one? That's just, it ended up on the wrong line. It's still correct. But yeah. So what I'm going to do is, this didn't seem to save us any time to speak of. Later, when we get really gnarly about optimizing, we might do this, but later restructurings of the way the scheduler works may do the equivalent of this naturally. So as fun as it was to type in all this code, I think I'm about to untype it. I'll save it like archivally, but we're not gonna check it in. Unless I'm missing something drastic. So we're going to paste that in there. Whoa, what? Right. Emac is having a cow because this file doesn't exist. I'm going to go doc simple decal experiment.cpp. Oh, no, not that. All right. I accidentally saved the whole file. Okay. What happened to my is simple? Oh, ask.h. Is simple decal. We're going to save that. And then interp. I'm just going to save this. Sometimes in programming, you gotta be willing to undo what you did for the greater good of all the people. I'm a little tired. We just had a few days of just like jamming, cranking ahead. You've never deleted work like that? Well, let me tell you, it's often a good decision. So look, we're running in about the same amount of time, and we don't have that additional complexity. You can't even tell. 0.527, 0.532. Same, but different. Okay. 41564. We just, that would be a much higher number if I didn't just delete all that stuff. Okay, let me add. add that for future reference. Um, It might still be worth doing this one because this one isn't that complicated. We'll see. But again, it's not by itself, it'll have even less of an impact on the numbers than the other one did. Okay, so now I want to hunt down unnecessary. Where did I put that? Yeah. Oh, I need to put that in my archive. And then my claim is we don't need this. Just shows that the regular code path is pretty fast. It is pretty fast, but it's going to get a lot faster. We are not going to rest. Okay, Sokoban still runs. Let's compile it in x64. 5.4 seconds, 5.39, 5.31. Run tests. Cranking along. Cranking along. All right. Are these all like white space changes? Oh, that's a line move. Let's audit this. Okay, so that's removing that. This is a white space difference. Great. It's okay. TM zone. Let's get rid of that. We don't need that zone. Well, comment it. Okay. That may be the end of the streaming tonight, or the official portion. We tried to do some optimizing, and it did not bear fruit, but that's fine. Oops, I unplugged my keyboard again. It's fine because it's like, okay, we tried that thing. We checked that off our list. Apparently, even though those are a substantial portion of declarations, they're also by far the least expensive declarations. So that's fine. Here's a funny thing, though. So the next thing to try, I don't want to try it tonight because I'm starting to get too tired. I'll mess it up. But, you know, when you say something is a primitive type like string or S32 or a bool, we actually look those up as a regular identifier right now. So the more scopes in, the longer it takes, even though all we do is we look up the global scope. So what we certainly could do is just short circuit those and say, well, those are, we know what those are. We know what those resolve to, right? And that, since identifier lookup still seems to take some time, that might be a good way to go. But again, it doesn't take nearly as much time as infer does. So really, maybe I shouldn't worry about that, and I should just deal with infer. And that'll be a big project. Maybe next weekend, I spend a whole day doing another large structural change. I don't know if I can finish that one in a day. That'll be rough, but it'll be fun to try. Maybe it's a weekend project. Massive stream weekend. So how are people doing? Have you had a good night? For those of you for whom it's night, still going through this whole week's footage. Yeah, there's a bunch of hours of stuff. There's about 2 hours in the one that's 4 hours. There's about 2 hours in the middle that you can skip because I'm just stuck debugging one thing that was stupid. So when you get to the part that's like, where's this memory corruption coming from? Just skip forward. Oh, you're in Japan. I was just there. I was just in Kyoto for a week and a couple days. Did I go to Bit Summit? Yeah, not for a long time. I kind of stopped by Bit Summit. And I was sort of more there to meet up with friends and then hang out and work on the compiler, as it turned out. I fixed a lot of bugs. The reason we got to the end of the bug list today was because I fixed a bunch of bugs in Kyoto. Oh, tomorrow is a holiday. For us too, we officially declared it a holiday. That means I could stay home and stream if I feel like it. I mean, I've been cranking pretty hard for the past few days, so I might want to make it a light streaming day, but it's quite possible that maybe I'll be dumb and try to do this big structural thing tomorrow, or we'll at least talk about it. I'll at least do a stream tomorrow where I talk about how the current flattening works, and then I talk about, what I want to do, and maybe I'll start doing it, and then we'll see. How's my trip to China? I had a good time. And, I gave this talk and it went well, and I got a cool Facebook picture out of it. Let me go onto Facebook and get the picture. I don't know if people have seen this. So, I gave this talk, and at the end, I was sort of shaking the hands of the translator and one of the guys who showed me around town. And it's just this real cool picture with the conference in the background. It's kind of a not ideal situation. This was more of a show to show games, and it wasn't really set up for speeches. So we had this stage, and then I guess this is security, this buffer zone here. Like China is very security conscious right now. So people had to stand way back. But it was a good time. I enjoyed my China trip. I'm actually not very buff right now. Back when I was doing serious kung fu, I had a lot more muscles than I have right now. What was the talk about? It was about how indie games sort of developed in the West, going from a niche thing to something that a lot of players were interested in, and about how that might or might not happen in China soon, and about how games are important because they'll be the phrase that I use is that they're the future of human thought, and I explain why that is. It was a short talk. It was 20 minutes, maybe 22 minutes total. And a lot of that was translation. I would say a sentence or two and then we would translate it. So it's on YouTube, actually. Let me see. I think it's on YouTube. I've seen a video somewhere. Let me try to find the video. Oh, actually, it's linked. It's linked from this Facebook post, if I remember correctly. Okay. So you go to www.gcores.com, articles 98265, and it's in Chinese. So if you don't speak Chinese, you will not read the text, but there's video here. Apparently they call me Santa Claus. I haven't watched the video because like I lived through it. Yeah. So that's a thing that happened. That was fun. I had a good time in China, and the people there, they took good care of me. They showed me around Beijing, and they were, you know, people in China are very good to guests. It makes me feel bad as an American for not being as good to guests as they were. What city am I living in these days? San Francisco, California. Who am I most inspired by? That's a rough question. I don't know. I mean, I'm inspired by little things here and there. I mean, I would say like, I use Elon Musk as a model for me not getting too lazy, right? Like if I think it's a lot of work to make a compiler and a game at the same time, like that dude did a car company and a rocket company at the same time. It's a little harder. So that's pretty good. Does Linus Torvalds inspire me? Not super much. But I don't know that much about what he does. So if I did, then maybe he would. His attitude certainly does not inspire me, but that's fine. He's entitled to that. Well, Boring Company's new, so what should you learn to get a job in the Bay Area? That is a very broad. There are so many jobs in the Bay Area, and they're all different. And so you would have to be very specific about your goals for me to say anything useful. What have I used for sound damping in this room? It used to be real echoey. Nothing. I just switched microphones. Like I probably used to be on the webcam mic, and now I'm using this mic that I used to have in Seattle, and it's right close to my face. So I think that helps a lot. Any suggested book or resource for C++? No, I just sort of learned C++ by osmosis, and I still don't know a lot of C++. Like, I got super uninterested in some things, some parts of C++, and those parts became a larger and larger proportion of C++ as the language got bigger and bigger. So, like, I don't ever do complex template programming in C++, for example. So if I were to sit down and try to do it, it would take me a long time to figure it out. It's just not the language that I program those things in. Yeah, I mean, that's the cool thing about Linus is that he sat down and said, I'm going to build an operating system kernel, and did it. Not like all the other people who sit around eating Cheetos all day, right? So that is definitely a respectable thing. Oh, right on. I'm glad you're self-taught and have a good job now. That's great. What is the most fun project I've ever worked on? I can't tell you. It is a game that I did in my spare time, that I prototyped in my spare time before the compiler, so around 2012, 2013, and that I want to come back and do as a full game at some point. And it's not announced, which is why I can't say anything about it. Except that it's not a puzzle game. What genre do I think I'll never work on? Visual novels or dating sims. Yeah, pay to win. I don't know if that's a genre, but pay to win is definitely in there. Yeah, it's the one with 40 hours of gameplay. Yeah, I've mentioned it before. Any multiplayer games I can recommend? Well, PUBG, if you want to put up with how broken it is. I've been playing PUBG. All right, it's been good hanging out. I am gonna go to bed, and I guess tomorrow we may have a streaming holiday, by which I mean I'm not at work, so maybe we stream some more programming, because I streamed a lot of hours in the past few days, but it's also been very productive. So let's see if we can keep it going. Wow, how many hours has it been today? Is the robot going? Let's see. 2 hours, 5 minutes. And I think the previous stream was also at least around 2 hours broadly. So we've done about 4 hours today, which is, more than a lot of people on Hacker News work in a day. Of course, some portion of that has been question and answers, but some of it was real work. Do I actively think about trying to make a game which will live 100 years? Yeah, in as much as I can. Like people who wrote novels 100 years ago, you can still read those. So why can't you make a game that's interesting to people 100 years from now and that will survive and be playable in some way? I think we should be trying to do that for sure. What is my work? I run a software company, which mostly, because I've got someone helping me do the organizational stuff now, mostly involves me sitting there programming and being grumpy at the other people in the company. All right, everyone. Thanks for stopping by. See you later. See you later.